Good morning, ladies and gentlemen. My name UD Limpraptono, and you can call me UD. I am a lecturer at Department of Electrical Engineering, National Institute of Technology, Malang, Indonesia. In the next 15 minutes, I will be talking about my paper on my project of remote lab. The purpose of this presentation is to introduce development of Internet of Things or IoT remote laboratory based on ESP32. I've divided my presentation into 5 parts, which are the background of the remote lab, including the definition and advantages of the remote lab, and then IoT remote laboratory, design and remote laboratory hardware and software, and then result and discussion and conclusion. Definition of the remote laboratory. Remote laboratory is an innovation in educational technology which allows students to access and interact with laboratory equipment through the internet. The advantages of the remote laboratory. The first, improve laboratory performance. Laboratory performance will be better and more efficient because laboratory equipment can be used by students for 24 hours, support distance learning, and create an autonomous learning, and can be used by handicapped students and support resource sharing. This paper proposes a remote laboratory system that is useful for studying and developing the Internet of Things (IoT) based on ESP32. The system is the result of a third-year research entitled Development of Remote Laboratory Architecture 4.0 as a learning solution in the era of the Industrial Revolution 4.0, which was funded by the Director General of Higher Education of the Indonesian Ministry of Education and Culture. IoT Remote Laboratory Architecture. The first, the IoT Remote Laboratory Architecture consists of 3 parts. First, an embedded web server based on Raspberry Pi 4 with an operating system based on Raspbian Linux. The embedded web server functions to control the IoT experiment module and functions to manage remote laboratory user. The server runs Apache Web Server application, MySQL database server, web-based user management application, and Arduino IDE application. The second is the hardware of the IoT experiment module consisting of several modules, namely an ESP32 based IoT module and several input and output I/O modules such as switch module, servo motor, stepper motor, and relay module. The third is the web camera unit that functions to remotely observe the experimental module. All sections are connected via a Wi-Fi based intranet network, and a remote laboratory system is connected to the internet via a router. Remote laboratory users can access various devices such as a PC, laptop, and mobile devices through the internet network. IoT remote laboratory hardware design you can see in the picture. And in the top of the picture is a Raspberry Pi 4 embedded system. The hardware used to control the experimental module, which a system on chip SoC with a computer. The Raspberry Pi 4 features the following Broadcom PCM2711 processor with a quad-core 1.5 GHz ARM Cortex CPU, have a RAM 2 GB and have a gigabyte Ethernet and two USB 2.0 port and have two USB uh, 3.0 port. And the Raspberry Pi 4 have a 40 pin of GPIO and have a Wi-Fi and Bluetooth and have a data storage micro SD card up to 64 gigabyte and have a HDMI port and use the operating system based on GNU Linux. And in the side uh, left side of the uh, picture, this is a ESP32 is a microcontroller module designed by a company based in Shanghai, China, namely Express System. The ESP32 offers a standalone Wi-Fi network solution as a bridge from the existing microcontroller to the Wi-Fi network. The ESP32 uses a dual-core processor. The ESP32 microcontroller can be used as an option for use in microcontroller interface probe because the microcontroller has a complete interface. It also has a Wi-Fi that is already embedded in the microcontroller, so it is appropriate for use on Internet of Things probe or trainer. And in the right side of the ESP32, this experiment module. The ESP32 development kit microcontroller module is the main part of the IoT remote laboratory. The ESP32 microcontroller module is equipped with various I/O modules, which are used as experimental module for IoT system development. Remote laboratory user can learn to develop ESP32 software with control object or various I/O modules such as a servo motor module, stepper motor module, relay module, and switch module. User can also develop IoT application based on the Blink Android applications. Result and discussion. In this section, we will discuss about testing the remote laboratory system that has been realized. The first step is to test the user management application, starting with the testing the sign up menu. Testing is done by doing sign up and trying to fill in the registration data on the menu that has been provided. On the register menu, user can fill in username, name and password data, and the menu uh, show in the screen. The next step is to test the reservation menu. by selecting the reservation menu and trying to select an experimental schedule. In the reservation menu, the user must select the date and determine the experimental session. If a remote laboratory user has selected an experiment execution schedule by selecting and desired session and date, other user will not be able to make a reservation on the same date and session. If the login success, user can open the remote lab uh, menu or remote lab website. And the next test is to try the Arduino IDE menu, where this application is used for the process of writing program code, compiling, process, and functioning to upload program code to the ESP32 microcontroller module. The Arduino IDE application is stored on the Raspberry Pi server, and to run the Arduino IDE application, it is done by clicking on the Arduino IDE menu. The program will be run remotely using the remote desktop connection application. Remote laboratory user can develop the ESP32 microcontroller programming code remotely using various internet browser. The Arduino IDE display in the screen. Remote laboratory testing is done by clicking on the remote laboratory menu. Then the web page will appear uh, as shown in the screen. The screen display consists of a real-time video display sent by the web camera unit located in the front of the experimental module. The video display serves to observe the experimental result, and on the right side of the web page, there is a control menu for the experimental module, namely put button for the process of running the ESP32 module, and the for switch button that can be used virtual input that can be run remotely. Okay, the conclusion of this project from the test result, it can be concluded that the entire IoT remote laboratory system can run well. All menus in the user management application and the experimental module control application can work well. The process of uploading the binary code into the ESP32 module and all input-output I/O equipment is also running well. This IoT remote laboratory system is expected to contribute to providing convenient in-learning IoT system, especially to support the distant learning process during the COVID-19 pandemic. Thank you.